All right, today we are going to talk about Le Chatelier's principle. Okay, it is a concept of equilibrium. So, what does Le Chatelier's principle state? When a system at equilibrium is disturbed, the system adjusts in a way to reduce the change. So, I always like to think of this in terms of real life. So, when your life is disrupted, right, you want to go back to a way that reduces that change. So let's say you lost your phone or you lost your water bottle. How do you reduce that change? Well, you try to replace your phone or water bottle, right? Just like how schools are in distance learning right now, we're trying to reduce that change by still having kids come to campus, right? So that's what Le Chatelier's principle is about. It's about minimizing change. So chemical equilibrium responds to three different kinds of changes in concentration, temperature, and pressure or volume. That applies to gases. We say that equilibrium shifts to the left if it forms more reactants, right? And it shifts to the right side if it forms more products. So remember, reactants are on the left, products are on the right. All right, so at equilibrium, things are balanced. We're going to use these pictures to help us illustrate Le Chatelier's principle. And so if we add more concentration of A and B, how does the system balance? What do we need more of to balance this? Well, we're going to need more C and D. So the system will naturally form more products, and we say equilibrium shifts to the right, as you can see here. Okay, so again, when we added more reactants, equilibrium shifted to the right, made more products to balance that out. What if we add more products? If we have more products, how would this system balance? Well, it's going to shift to the left. We need more reactants to balance it out. So when you add more products, equilibrium shifts to the left. Okay, so notice when you add something, equilibrium tends to shift to the opposite side. What if we take away something? In this case, if we took away C and D, how would equilibrium shift? If you lose something, what happens? Well, the system's going to try to replace whatever is lost. And so we say equilibrium would shift to the right because we lost some products, C and D, so equilibrium will try to fix that by making more of what you lost. It is going to shift to the right and form more products. Okay, so whenever you lose something, equilibrium tends to shift to the same side. What about temperature? So endothermic heat is absorbed. When we talk about these reactions, in an endothermic reaction, heat can be considered a reactant. So we might even write it in the chemical equation like so. So heat, again, is a reactant. It's on the left side of the equation here, right, because this is endothermic. We need heat in order to break down this chemical, NH4Cl. Exothermic is the opposite. If it's an exothermic reaction, then heat will be written on the right side. Okay, and we consider it a reactant if it's on the left, a product if it's on the right side. So when we're talking about equilibrium changes, increasing temperature, right, that's the same as increasing our reactants. It's on the left side here. So if we increase something on the left side, equilibrium will shift to the opposite side to make up for that increase. Okay? What if we took away that same heat, right? Whenever you take something away, equilibrium shifts to the same side that you lost something. It wants to form more of whatever you lost. So in this case, equilibrium would shift to the left. And that's, again, an endothermic reaction, right? Because heat is on the left side. For this exothermic reaction, let's take a look. If we increase the temperature, here the temperature is on the right side. So if we increase something on the right side, equilibrium is going to want to form more things on the left side to balance that out. Okay? We need more products to balance that out. And again, if you take away something, in this case heat, on the right side, equilibrium will shift to the same side to kind of fix that, to make up for that loss, right? Like if you lose your phone, you're going to try to get another phone. So if we lose heat here, we're going to try to form more heat and products. Okay, lastly, equilibrium responds to changes in pressure. Pressure depends on the amount of moles of gas. More moles of gas, more pressure. So if there's an increase in pressure, equilibrium will shift to the side with less moles of gas. So we have to actually count how many moles of gas there are. So in this example, we've got 3 moles of gas on the left side compared to 2 on the right side. So increase in pressure favors the side with less moles. So which side would this shift to? Here, as you can see, it's going to shift to the right. Increase in pressure. Okay. Let's try another example. Which side has less moles of gas here? So 2 chemicals versus 1. So the right side has less moles of gas. Increasing pressure shifts equilibrium to the side with less moles of gas, in this case, the right side. Okay, so the opposite's also true. If you increase volume or decrease pressure, then it would go to the side with more moles of gas. Equilibrium shifts to the side with more moles of gas. Remember, pressure and volume are inversely related. All right, lastly, how to complete this table. This is the last thing on your worksheet. So if equilibrium shifts to the right, the first example is done for you. That means we're making more products, but we're using up reactants to make those products. Okay? So that's if equilibrium shifts to the right. So when you add a reactant here, nitrogen, then we're going to need to balance that out by forming more products. So we see an increase in products, but to make those products, we have to use up some reactants. Okay? So this one's going to be similar. This is also going to be a shift to the right because this is a reactant. And so nitrogen, right, we would have to use up some nitrogen, and this would form more products. Anytime it shifts to the right, you're forming more products. Okay. What if it shifts to the left? If we remove nitrogen, equilibrium would shift to the left. Anytime equilibrium shifts to the left, you're forming more reactants. Okay, and we're using up products. Okay, so do your best to fill in this table. I would complete this first column first, see which direction equilibrium shifts, and if it's right, then you're forming more products. If it's shifting to the left, you're going to form more reactants while decreasing products. Okay? All right. Good luck. We'll definitely go over this in the future. The last slide sums up